Who helped me with the recording? One former students. Click recording. Ah, because it's stop recording. No, it's okay. It's recording now. Okay. I suppose. Okay. I suppose it's recording. I'm not sure because normally the bottom put in red color. But now it's blue color. Well, maybe Sky, update sometime. Okay, entonces the idea is focus, guys, focus. Are you ready to pay attention or no? Yes or no? Not ready?
Yes.
Okay, both expressions, P and Q, are polynomial. And together, in this format, division is a rational function. It's easy to understand this. I bring today several examples of the most important characteristic of the rational function. We discussed a little bit, not too in details, the verified asymptote. We continue verified asymptote a little bit. Example 1. Example 1 say f of x is equal to divided by x minus 3. Oh, it's easy. 2 have no x, therefore the degree of this polynomial is 0. And x minus 1, the exponent is 1. So the degree is obviously 1. Okay? But I don't care that part. The important part now is I try to do the graph of this function. Entonces I can see the expression in the bottom is x minus 3. When you put it equal to 0, okay, by the way, the solution is x equal to 3. It represents a verified asymptote. You are doing something like that. You are doing something like that. You do the graph. Let's do the graph roughly, and after you see in decimals, no? 0. Completely horizontal line. This is x-axis. Entonces, en 3. Suppose que this is 0, no? 0, 1, 2, and 3. We have the famous verified asymptote. Remember, the verified asymptote always we represent verified 90 degree, verified line. Represent a auxiliary construction to help me to understand. It always is, dotted line. These don't belong to the curve. However, it's auxiliary construction can help me to understand the curve. Because I know que the verified asymptote the curve approach pero never touch. Okay, entonces remember que we have different behavior of the verified asymptote. To determine the behavior, you approach it to the left and to the right. To the left, you select completely arbitrary value, suppose x equal 2, or 2, or 1, or 0, or -1, to the left, I recommend close to the asymptote. This is the verified asymptote. I recommend close. And you evaluate the function in 2. It's 2 over 2 minus 3, que es -1. Entonces 2 divided by -1 is -2. Wow, it's -2. And -2, when you plot that, let me put definitely the y-axis. Why now? The y-axis here, over there. Well, y-axis now here. The point is the point 2, -2, no? 2 was the x, -2 was the y. Plot that. -1, positive 1, positive 2, -1, -2. The point is here. Let me use some red color. This point is a point 2, -2. Now, suppose you need to understand what's going on after the vertical asymptote. So I compute to the right. And I select completely arbitrary, suppose 4. Remember our asymptote is 3, no? So I select 4. Or 5 or 6. 4, it's okay, close. You are F in 4. Entonces es 2 over 4 minus 3. Wow, it's 1. Entonces 2 divided by 1 is 2. And the point is 4,2. Okay, you plot the point 4,2. 4,2. 4 is here, 2 is here. And I have no super accuracy idea, but a roughly idea how look like the behavior of this. Okay, we complement this idea with another technique that we studied throughout the chapter. But okay, at least you determine the vertical asymptote taking the expression and the denominator you are forcing to be equal to 0. This is my vertical asymptote. But remember, we have 4 kinds of behavior. Now you evaluate a little bit after and a little bit before the asymptote. And you say, well, in this case, after is positive, before is negative, and this is the behavior. Clear? Just in case, to verify it's super fantastic, we put in decimal always, anytime. Nobody doing in the piece of paper. No, hello, you know that. Okay, so now I want to share a little bit now decimals. Wait a second. Okay, there you go. I saw that the features in Sky changed. Now it's no red color, blue color. Okay, no problem. Okay, now, let me see. Do you see Desmos now? Do you see Desmos? Do you see?
Yes.
Yes.
Okay, look at my first example. This is my first example. My first example was the function 2 over x minus 3. I determined que at the value x equal 3 is a vertical asymptote. Look at that, I flash in this. And 2.4 and 2 evaluate the function. This is the beautiful of Desmos. You define instead of y, you can put a y here, but I prefer f of x because you evaluate and 4 automatically give me the value get 2 and negative 2, and this is my graph. Bam. Everyone follow me? Nice.
Yes.
Okay, let's move on to the second example. Let me share screen. Whiteboard. Come back. Do you see whiteboard? Do you see? Do
Yes.
you see? May I erase everything?
Yeah.
Okay. Okay, example 2 now. Example 2 is a little bit more interesting because bring me a new idea. Suppose the function is called g equal x minus 3 divided by x squared minus 5x plus 6. Okay, guys, the first thing you should do always to analyze any rational function is expressed in factorial form. Now you take the expression on the top. In this case, it's impossible to do something because it's a binomial, easy binomial. However, in the bottom, no, in the bottom is trinomial and you factorization. In this case, is the combination is 3 and 2 because 3 times 2 is 6 and 3 plus 2 is 5, both negative. Okay, now immediately you see that, you see, wow, this factor is cancelled. And the factor is cancelled always represent a wholes. And the factor can stay in the bottom, So in the top we have nothing. Nothing is 1. And the bottom is x minus 2. So the factor can stay alive, and the bottom is a vertical asymptote. But both points, so you say, well, what is the domain of this? The domain of this is all real number except the whole, okay, add 3, add the vertical asymptote case and 2. So we have undefined, but in different way, because it's a whole or when it's a vertical asymptote. Okay, I understand. Now you, for example, you take the expression and the denominator and force it to be equal to 0. It's obvious. Okay, it's x equal to. So I know. Okay, add x equal to. Wow, well, this is the y-axis. Let me take advantage. Okay, on the axis, another axis is x-axis 0 degree. Okay, horizontal. Okay, so I know que add x equal to, this is 0, this is 1, this is 2, this is 3, this is 4, and so on. This is x-axis. And 2, we have the famous vertical asymptote. 90 degree, dotted line, vertical line. Okay, 90 degree here and 2. Okay, this is a symbolic way, guys, to indicate vertical asymptote. Well, any asymptote. We study another asymptote. But this is vertical. Okay, it's dotted line. Now I need to understand the behavior. The behavior is, well, I select a little bit number before and after 2. But in 3, no, because in 3 is a whole. So no. I avoid the 3. No, 3 no. 3 because it's undefined also, no? Okay, therefore, I, for example, evaluate the function in 1, g, evaluate in 1. So the question is, one, plugging in, and the original, or in the new one. In the new one gets easier. Well, because the answer is in the same, it's the same value. So this expression are equivalent except the whole que I delete. And so you write something like that, G, this is the new one, let me call G1 in X. What is the difference between G1 and G original? Well, G original is equal G1 always, except at x equal 3, because at x equal 3 we have a whole. Okay, you cannot plug in 3 here because to be undefined. You can plug in 3, yes, but what is the meaning of this? What is the y value of the whole? Okay, let me explain in detail. Don't worry for this. This looks like complicated, but actually it's not complicated. Entonces, my recommendation is plugging in directly in the easy, que es 1 minus 2 is 1 over negative 1 is negative 1. And the point is the point 1 comma negative 1. I plot that. 1 comma negative 1 is here. Boom. It's negative 1. It's a positive 1 in x. Okay, now evaluate at 3, no. After, no, pero no, because it's undefined, no, I suppose, and the G, and the original G, no? You evaluate 4, why no? Entonces es 1 over, again, we plug in G1, que es the easy, no? 4 minus 2 is 1 over half, it says 1 over 2. 4 minus 2 is 2. Entonces the point is the point 4 comma 1 half, positive 1 half. Positive 1 half, 4 comma positive 1 half. So I suppose that this is 1, the half is here. Okay, this point is a point 4 comma 1 half. That point was 1 comma negative 1. Entonces I know that their behavior look like that. Approximately, you know, roughly sketch. Now, what's going on in 3? Oh, in 3 we have a hole, remember, right? And I cannot, so now the hole is located here in 3. A hole. And the representation for the hole, you erase that part, okay, and you put in the same color of the color que you select for doing the graph of the it's a hole. But exactly what is the y associated with the hole? Well, to find the y, well, actually, G evaluated 3 is undefined. Likewise, G evaluated 2 is also undefined for different reasons, but it's undefined. This is a hole, and this is baric acid. But if you want to find the y, the hypothetical position for the hole, you evaluate G1. The G1 evaluating 3 is 1 over 3 minus 2. 3 minus 2 is 1, with 1 divided by 1 is 1. Therefore, at the point 3, 1 is the position of the hole. Actually, is the hole, you know, is 3, undefined. But to have some geometrical idea, you evaluate in G1. Entonces, this sketch que I do is horrible. It's not good. Let me erase this. Okay, it's 3, 1 here. Hole. Okay, and 4 half. 1 half. Approximately. But no hole. Here, no hole. This is the point. Okay. Do you understand this idea? Okay, just in case. No good. By hand, it's not good. Always decimals. You put in decimals and see what's happening. Okay, switching to decimals. I suppose you see the decimal now. You see or no? Do you see or no?
Yes.
Okay, let's move on to the example 2. This is the example 2. Look, in the example 2, you can see clear. Okay, we have 1 baric acid to add 2, but we have a function. This is my function. Look. Okay, this is my function. Okay, have 1 hole at 3. This is the position 3, 1. But actually it's undefined. And by curiosity, let me see the difference. I try to make the graph of G1. Okay, similar, no? You expect similar. Let me see. G1 is using different color, using red color. But the graph of G1 and the graph of the original G is exactly the same, except in 3. G have a hole. G1 have no hole. Only the same as the rest of the values. So you can plug it in, you can use it. G1 instead of G for evaluate any point different to 3. The idea is clear or very, very, very confusing? Clear or confusing? Come on.
It's clear.
Okay. Let's move again to the whiteboard. Okay, I want to erase everything. Clear whiteboard. And we want to discuss a new topic. A new topic is a horizontal asymptote. Wow, horizontal. Horizontal asymptote. So we have in this kind of functions, we have different asymptotes. Okay, we're discussing everything today, but we analyze step by step. after I promise que I give you a guideline to evaluate to analyze the rational function. But one important thing is a horizontal. Let me definition first. Definition to understand what the hell is that. Definition of horizontal. Asymptote. Okay, this is similar to the end behavior that we studied in polynomials. End behavior means that x approaches to positive infinity or x approaches to negative infinity. So in both directions, we have, for example, the all real number line. I want to investigate horizontal. I want to investigate what is the value of our new function, no polynomial, rational. This is different, completely different idea. When this is my all real number line. Okay. And this is x, and that direction, x approaches to infinity. That idea means that you evaluate the function in a huge number, 1 million, 10 million, or in the opposite direction. So when the x approaches to negative infinity. It's a huge number also, but negative. Okay, and my goal is determine what is the f of x can approach it in that situation. Okay, in general, let's see now, it's a number, D, a number, or zero, well, a number in general, okay? It's a little bit different to the polynomial. Okay, so we have, to understand this, we have different scenarios, we have different cases. The first case is a regular case, is if, remember, the function is formed by two polynomials. Suppose que the degree, so suppose the degree. This is important, guys, analysis of the degree. Degree of this and degree of this. See, the degree is the same. Degree of P is equal, the same degree of the degree of Q. I guarantee you 100%. Okay, we have, yes, we have horizontal. Okay, see, the degree is the same. Because, what is the reason? Because the degree give me information about how fast increasing or decreasing our polynomial. Entonces, for example, this is a complementary example. Suppose in one function f of x equals 7x squared plus 2x divided by 4x squared minus 3. Entonces, I only ask the question is, we have or we have no horizontal. Okay, let me try. Analysis of the degree. Degree of the polynomial at the top is 2. It's obvious, right? Degree 2. Degree of the polynomial at the bottom is also 2. Okay, so according to this rule, yes, we have. Yes, we have horizontals. Okay, but I want to discuss it more. Okay, to analyze exactly in what position is located the horizontal asymptote, you try to find the dominant. What is the dominant? Dominant terms. Okay, so one approximation of the f of x is dominant. You take in the top the monomial que have the higher degree, que es 7x squared. What is the reason I do that? The reason is because x approaches to infinity. So a is a huge number. Obviously, when you plug in x equal a huge number, the term increasing faster is this. And this is completely negligible. Okay, it's big, but it's negligible with respect the other que es the dominant. And likewise, the dominant and the denominator is 4. So you take the higher degree of monomial. Es obvio que the parts cancel out. And stay alive 7/4. And this represent the value for the horizontal asymptote. So this famous value que I call in one moment D is this. I can affirm, yes, that function, it has a horizontal asymptote at x, y equals, sorry, no x, y equals 7/4 because it's a horizontal line, no? Like that. Do you follow me?
Yes.
Okay. Entonces I bring 2 examples to determine si you understand or not very well. For example, complementary example. Let me call example, I don't know, 2 and 3. Because this guy was one of specific that part, the horizontal, no? Example 2, example 3. The first example is called h of x is equal ax squared plus 9 x minus 5 is the polynomial at the top. The polynomial at the bottom is 2x squared plus 1. The second is p of x function, rational function, is x squared plus 7 divided by 11 minus x squared. My question is, example 1. Let's focus on the example 1. We have horizontal asymptote, yes or no? Horizontal asymptote. We have yes or no?
Yes.
Why? He said yes. Because have the same degree. Degree of the polynomial at the top is 2. Degree of the polynomial at the bottom is 3. Okay, super. Entonces, es yes. Entonces, my next question. At what value? Y equals something. At what value? What value? Because it's horizontal, I understand. But at what value? X, Y. What is the value of this? Y, what is the equation of the horizontals? Y equals something. The dominant idea. What is the dominant expression? Say again?
8/2.
A/2. A/2. A/2, who is A/2, miss?
Huh?
Who is A/2?
8x squared over 2x squared.
No. Okay. A squared, she said. Okay. No, come on. What is your idea? She said, okay, you don't need to repeat again my step. You automatically, you see, bueno, you take the dominante and the degree is the same, entonces A/2. A/2, pero A/2 es 4, ¿no? That's it. Entonces, yes, the conclusion is, yes, we have horizontal asymptote at y equals 4. Okay? And you are doing the important famous line and dotted line at y equals 4. What do you think about the second example? We have yes or no? Horizontal asymptote. No, yes or no? Yes or no? Opinion. I want to hear. Yes, he said yes. I agree with him. Why, mister?
They have the same degree as well.
Exactly, because they are same degree, 2. Entonces, my complementary question is, at what value? Y equals something?
7/11.
No. What is the dominant? What is the dominant? I put intentionally to confuse you. Okay,
It's
what
gonna
is
be 1.
1 or negative 1?
-1.
Negative.
Negative 1. Very well. Okay. You take the monomial that have the higher degree in the top and the bottom. I put it to confuse you in different order, right? This, I am bad guy. Now, actually, it's x squared divided by minus x squared. It's obvious it's negative 1. This is the value for the horizontal. Clear? Clear? I promise this part we are discussing now is like a theoretical. So when you finish the whole detail in the theoretical part, I will give you the guideline to analyze any rational function, and we are doing several examples. In the review packet, we go over again to this. Okay. We finished the topic of the horizontal? No. Why no, professor? Because we have another cases que es like a special case. So this is the regular case. The regular case is when the degree is the same. However, we have another possibility of the horizontal asymptote when the degree, okay, again, the same repetition, P divided by Q. Suppose que the degree of Q is bigger. Degree of P. In this case, we have also horizontal asymptote. But this is special. This is at y equals 0. This is at y equals 0. And it's logical because the degree of the P is bigger than the degree of Q. That means that this polynomial increasing faster than this. Both increasing, but this increasing super faster than this. And when you have a division and the denominator increases faster, it's obvious that the answer for the quotient approaches to 0. Let's see example. Suppose that we have example 5, no? F5. F5, no?
I think it's 4.
F4, okay, F4. Example 4, she said. Suppose this. For x equal 5 divided by 4 x squared plus 9. Well, as always, when you try to analyze the horizontal asymptote, you are doing the degree analysis. Degree of the polynomial in the top is 0 because we have no x. Degree of the polynomial in the bottom is 2. Entonces I see that the degree of Q is bigger than, entonces we have the special case of the horizontal, and the answer is yes, we have. Yes, we have at y equals 0. Okay, don't forget, we have two possibilities to have horizontal. Same degree, or the degree on the bottom is bigger. Bigger than 1 by 2 by 4. Doesn't matter the differences, but it is bigger, the polynomial on the bottom increasing faster. Okay? Do you understand very well this or no? Yes or no?
Yes.
So I continue to analyze horizontal asymptote, but another idea, another idea, another important idea. Sometime the curve, okay, look, sometime the curve, suppose this is the horizontal asymptote. Y equals something, I don't know, and we have vertical asymptote here. X equals something. The curve never touch the horizontal. Approach pero never touch. Suppose que it's like that. Suppose I need to investigate behavior a little bit left and right. Si both are positive, it's like that. Si es negative, entonces down. However, in the horizontal happen different situation. The curve may be touch or crossed in one point the horizontal. This situation not always happen. In my opinion, seldom happen. But you need to investigate this important point. I bring an example to illustrate this idea. Look, suppose the function f of x equal 8x squared plus 9 minus 5 divided by 2x squared plus 1. Okay, by the way, it's exactly the example we put it before. Okay, I don't want to repeat because you see before, yes, we have horizontal asymptote at y equal 4, right? You remember that, right? A few minutes ago, we discussing this guy. What is the new thing I want to discuss? The new thing I want to discuss is if exists one point, see, because always is one. See, exists, the answer is yes or no, do not exist or exist. One point in which this graph crossed this asymptote. Why not to investigate this idea? You enforce it, you copy this expression. Okay, and you enforce it to be equal. So we have two possibilities. This equation, you solve this equation, solve for x. When you solve for x, suppose you get one solution. Nice. Entonces we discover this famous point. Sometimes happens, it never, because the majority of the scenarios, the graph approach but never touch. And then we have no solution in this equation. Okay, let's try. To find the solution, you apply cross multiply. 4 is a whole number, denominator is 1, so you cross multiply, and multiplication this guy times this guy, and this guy times this guy. Entonces 8x squared plus 9x minus 5 times 1, one is invisible multiplier, times 4 times 2x squared plus 1. Entonces this is the equation I need to solve. I try to do my best. X squared, 8x squared, 9x minus 5. And you apply this distributed here. This is 8x squared plus 4. Wow, look at that. Fantastic. I like that. This guy is the same. Therefore, I can cancel out. So when you have the same in the right and the left, you can cancel out. Or it's equivalent to say when you have positive and negative in the same side. No? So my equation is stay easy and solve for x. Linear equation is equal to 4 plus 5 get 9 divided by 9 is obvious que 1. X equal 1. So the conclusion is yes, exists the famous point in which the graph crossed, and you see now in Desmos, crossed the curve, cross the horizontal asymptote at the point x equal 1. Now, if you want, help me to understand this. If you want to express it, this important point as other pairs, I know that the component is x comma y, no? X is equal 1. What is the value for the y? in this specific example? Tell me.
4.
Exactly. You are the best. It's 4. It's obvious, right? Also, now I want to see to make sure that we're doing well or no in the decimals, no? In decimals. Let's go to decimals. Select decimals. Do you see decimals? Okay, that was example 2. Now example 3. I call example 3. Look at that. It's my function. I investigate. The horizontal has to look at y equal 4. And this is the famous point 1, 4, que is the point in which the curve, que es red color, crosses the horizontal axis. Okay. Entonces es mandatory. When you have horizontal asymptote, investigate if the curve crosses or not. You see another example that this point do not exist because when you try to solve them, you have no solution. Entonces, no solution es que means que do not exist. Okay, everyone follow me? Okay, entonces keep in mind, let me summarize quickly. When we have horizontal asymptote in two situations, the regular case is when the polynomial on the top and polynomial at the bottom have the same degree. We have. How you determine the position for the horizontal? When you take the dominant in the top, the dominant in the bottom, and divide each other, and you determine the y value. Another scenario, que es the special, is when the degree of the q, que is the polynomial in the bottom, is bigger. In this case, yes, we have, but at y equals 0. Okay, I call it special case. Everyone follow me?
Yes.
Okay, let me try to switch again to the whiteboard. I am here, whiteboard. You see whiteboard? Yes. Now I want to discussing. I switch into another topic. No. Inside the same, the slang asymptote. Because I promise it's the last one. Asymptote. Slang asymptote. What indicate the word slant? It's a oblique. So normally we study so far vertical asymptote. We study horizontal. Now we study another kind, que is slant. Slant is oblique line. Slant asymptote. Okay, maybe like that or maybe like that, depending on the problem. So basically it's a line. The equation of the line you know very well, que es y equal mx plus b. And depending on the slope, si es positive, it's in that direction, or it's negative in that direction. Okay? And similar situation happen. The curve here approach but never touch. The curve here approach but never touch or seldom cross. And here sometimes is similar to the horizontal, sometimes cross. Pero very, very, very seldom. This is an example of this, but no. Okay, so how do you know? What is the feature? What is the characteristic that give me if we have a slant or no? Well, the degree analysis again. If the degree, so again, we have the situation, okay, we have rational function, f of x is equal to p of x divided by q, polynomial to polynomial. But in this case, the degree of p is equal to the degree of q plus 1. No plus 2, no plus 3, plus 1. Example, ¿dónde está? Elementary example. Suppose x squared plus 1 divided by x minus 1. Es obvio que the degree of the polynomial in the top is 2. Y es obvio que the degree of the polynomial in the bottom is 1. Entonces, the degree of the polynomial p is equal the degree of the polynomial q plus 1. No plus 2, no plus 3. Suppose that the degree is 3 and 1. No. Exactly plus 1. Okay, maybe 3 and 2. It's okay. Okay, or 2 and 1. Entonces, well, okay. Entonces, this is the, yeah, when you see this immediately and do an analysis of the degree, I say, yes, we have. Yes, we have what? We have a slant last. The problem is how you determine slant. Okay, let's do it. You perform a long division or synthetic division, either way, and between the polynomial. Let's do first of all long division. Either way, the student can prefer long division, the student can prefer synthetic division. It doesn't matter. You copy here. This is the typical format for the long division. You copy the polynomial at the top, gets x squared, okay, plus, well, it's missing the x part. Here is missing. You can consider it as x squared plus 0x plus 1. No, be careful. This is important detail. Plus 1. You copy this inside in the format of the long division. See, one term is missing, you put 0 in order to keep the organization for the long division. And here the divisor is x minus 1. Okay, ready. Entonces x, because x, so remember, you need to find one expression can multiply by divisor. Give me, or no, at least the first, give me exactly the same of this. X times x, x squared. And this is minus x. Minus 1x, no? By subtracting, you change the sign. Is it cancelled? And it's a 1x. I finish? No, I do not finish because we finish when the remainder is one polynomial of the degree less than 1, the divisor. See, the degree of the divisor is 1. You finish when you have a constant here. Okay, because I bring down 1. If you want, you delete this 1. It's invisible, multiply. Either way. And finally, it's plus 1, no? Plus 1, plus 1, plus 1. Plus 1, because 1 times x is exactly the same we need, is x. And 1 times negative 1 is negative 1. By subtracting, you change the sign. This is cancelled, and this is 2. Okay, so I finish the division because degree 0, degree 1, so the degree of this guy is 1. Degree of this guy is 0. And the degree of the remainder is less than degree of the divisor. Stop the long division. Now we can represent the original problem, case x squared plus 1 divided by x minus 1. You can represent like a quotient, is this is x plus 1 plus the remainder gets 2 in our example divided by x minus 1. Now these expressions are completely equivalent. Okay, however, I can see clear like water that this part represents the slant asymptote. Okay, so in conclusion, y equal x plus 1 represent our slant asymptote. And to do the graph of this is super easy. Because you remember that this is equivalent to say y equal mx plus b, no? So suppose that we're doing the rectangular coordinate system quickly, no? Because I don't want to dedicate too much time to explain the idea because it's easy. is, look, is this, I focus on this. I know that B is 1, so Y-Intercept is 1. I plot the point 0,1 because B is 1. And the slope is also 1. Entonces, right and wrong. Remember the definition of slope is right and wrong. It's the ratio between two quantities. It's called right and wrong. Right is upward or downward, and wrong is always to the right. Entonces, to the right, and in this case, it's upward because it's positive, no? Okay, this is right and wrong. And you determine the second point, and 2 points is enough to plot the slant asymptote. Okay. By the way, this is just curiosity. Anyone follow me so far? The thing is, determine the exists or no the slant. And this is the analysis of the degree. If the degree of the polynomial in the top is bigger than 1, the degree of the polynomial, automatically you say, yes, we have. But at what value? At what expression? You are doing long division or synthetic division. You want I do by synthetic division again, and you seek a super issue. And you take the linear factor, the linear expression in the front, get this. And this represents the slant. And this is the equation. Okay, let me try to do the same job using synthetic division for the people who prefer synthetic division. And remember, long division is general. You can divide any polynomial divided by another any polynomial. It doesn't matter the degree. It doesn't matter, independent of the degree, regardless the degree. Synthetic, no. Synthetic is easier or shortcut when the degree of the divisor is 1. Otherwise, no. Otherwise, no. But in this case, yes, because it's the degree is 1. So you are doing by synthetic division, the student can prefer synthetic division. Why don't you put in the format get 1, 0, 1. Look, coefficients 1, 0, 1. Remember, this guy is x to the 0, this guy is x to the 1, this guy is x to the 2nd. Okay, super. Now, in the divisor, you put the opposite sign to the factor, in this case 1. So in our long division, you put -1 as a factor, but in the synthetic division, no, you put the opposite sign. Bring down 1, 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, this is 2. Remainder 2, that means that x minus 1 is no factor of this polynomial, but this is a remainder, this 2 is this 2. And this is x to the 0, and this is x to the 1, que es the slant asymptote, que es x plus 1. End the story. Okay? Yeah, out the game. Curiosity. This rational function have one slant, but we have also vertical. Look at that. You take the factor in the bottom, x minus 1 equal to 0, x equal 1, represent our slant here. Our slant, no, sorry, our vertical. So we have slant here and vertical here. Slant, the equation is y equal x plus 1. And vertical is equation is x equal 1. No y, because the vertical line. So now suppose you have to see more clear the graph of the hour. Okay, let's do it. Pero no, it's complicated because we analyze several things. The graph, I anticipate you. Okay, look like that. Just in case you want, I show you in Desmos the idea for this example. You understand very well or no? Complicated or easy? Let's practice one more of the slant. Come on, guys, feedback. I need information. You follow me? You are lost? Yeah?
Good so far. Good so far.
Good so far, okay. No, I feel that this is good class. I feel. But okay. But maybe I need to make sure, no? Okay, let's see another example of the slang. Another example. Suppose this function f of x equal 2x squared minus 5x minus 3 divided by x minus 2. Okay, we focus in the problem of the slang asymptote. Question number 1. We have or no?
Yes.
Look,
Yes.
Yes, why? She said yes. And now complete the idea with the reason. What is the reason? Okay, yes. Because
The degree 2 equals the degree of p. A plus 1.
Degree, again, is the analysis of the degree. Degree of the polynomial on the top is 2. Degree of the polynomial in the bottom is 1, is linear. Therefore, this is 1 plus 1 is equal to. Yes, we have. We have what? Horizontals. Slang, sorry. Now, to find the equation for the slang, we need to do the division. Long division or synthetic division. What do you prefer? Synthetic division or long division? Or we are doing both. What do you think? What do you prefer? Synthetic division or long division? How do you feel more comfortable? Doing the long division or synthetic division?
Long division.
Long division. He say long division. Okay. I respect. Long division. Long division, the format look like that. 2x squared minus 5x minus 3. This is dividend, and divisor is x minus 2. Ready to start. It's 2x, no? 2x because 2x times x is 2x squared. And 2x times minus 2 is minus 4. By subtracting, you change the sign. Cancel out. This is negative x minus 3. And we continue, of course, because we stop when the degree of the remainder is 0 in this case. And then is negative 1, I guess so, no? Negative 1, because negative 1 times x is minus x. And negative 1 is positive 2. Positive 2. By subtracting, change the sign. So you change the sign, this guy is positive now, and this guy is negative. Subtracting is negative 5. Therefore, this expression gets given at the beginning is equivalent to x minus 2 minus 5 divided by x minus 2. Okay? Therefore, wait. I make a mistake. This is this. This is the asymptote. No, this is the divisor. Divisor is this. Okay, I write this as 2x minus 1. Okay, to say, let me complete the idea. The idea is, yes, we have slang asymptote at the line y equal to x minus 1. Entonces, in this line, I can see que es low is 2, and b, que es the y-intercept is negative 1. Entonces, you want to do the graph of this, a scissor, you plot the point here, que es the point 0, negative 1, and from this point, you apply wrong and rise. Rise is 2, wrong is 1, because it's a whole number, right? So 2, I move it 2 to the over, 1, 2 here, and 1 to the right. You get the second point, and we plot the line. At least we have the equation for the slang asymptote. the graphic of the slang acid. By the way, curiosity, we have baric acid in this problem or no? No. Exist or do not exist baric? What is the criteria to find the baric? It was the first we studied. What is the criteria to find the baric acid? Nobody remember that? Hey guys, come on, answer me. No?
If the degrees are the same.
No. Baric acid do not depend of the degree. This is you confused, horizontal. You need to organize your brains. Okay, to find baric acid, the only thing you should do is take the expression in the denominator, que is x minus 2 equal to 0. Entonces, at x equal to, we have baric acid. Okay, don't confuse horizontal. Horizontal and slang, we need to do the analysis of the degree. Baric no. Baric is only you take the factors and the denominator, you enforce it to be 0 because this is undefined. Okay? And by the way, I need to explain one more idea. The slang acetone versus horizontal acetone. Here is when the degree is the same degree. Or degree of Q bigger than degree of P. This is for this. This is the regular case, and this is the special case. Special is when the y is 0. And regular no, it's when the y equals the division, the leading coefficient. Suppose ax squared divided by 4x squared is 2. And slang is when the degree of P is bigger than 1, equal, I put it equal, degree of Q plus 1. Entonces, these concepts are completely mutually exclusive. Si we have horizontal, definitely we have no slang. No. And si we have slang, we have no horizontal. Pero both is impossible. Clear? Clear?
Yes.
And don't forget vertical. Vertical is completely no degree. I don't care the degree. I take the remaining factor after the simplification. Okay. Let me try to recap, because this is complicated. Not complicated, but it's too long. The first thing you should do when you face one problem of the rational function is you express it in factory form. Factorization of the polynomial at the top, factorization of the polynomial at the bottom. When I say factorization, you apply any technique that we learn of the factorization polynomial. Maybe the regular factorization like intermediate algebra or scientific division. Or the combination with the Desmos and scientific division. Okay, ready. I factor both polynomials. The factor que es cancelado, boom, represent wholes. No asymptote. The factor que stay alive in the denominator, you enforce it one by one to be equal to 0, and this determine the baric acid. Okay? The horizontal, no. The horizontal is, you analyze the degree. You have the special or regular case, and the slang, you are doing long division or scientific division, either way. Okay, entonces this is a moment, crucial moment to give you the guideline for doing graphic irrational. Okay. So I highly recommend do it exactly. Stay here. Graphic. Interchange R. Okay. Entonces my recommendation is. Do exactly the same I want to explain now. Step 1, step 2, step 3, step 5. Actually, we have 7 steps. Okay. Okay. What is the first step? Well, the first step is expressed in factory form. So we have, okay, you can say, for example, P and Q, f of x is equal to P of x divided by Q of x. And they, who is they? PQ, P and Q polynomial. With no common factor. In other words, determine the wholes. Suppose we have x minus 1, x plus 2, x minus 3, divided by x minus 1, x plus 2, x minus 5. You see clear that this factor is cancelled. This factor is cancelled, and my expression stays x minus 3 divided by x minus 5. Okay. What happened with the whole? How many whole? What position is a whole? No, the factor gets cancelled is a whole. At x equal 1 y at x equal minus 2 is a whole. And what about this guy? This is verical asymptote. So we have verical asymptote at x equal 5. And by the way, everything is undefined. For different reasons, but it's undefined. Okay, the conclusion. Fantastic conclusion. The first thing that you should do when you analyze rational function is factorization of the polynomial at the top, factorization of the polynomial at the bottom. You simplify, the common factor is gone, and the factor that stays is the expression that we continue doing this. You continue here and the step 2 using this. Under the consideration that we have a whole and the factor is cancelled. Got it? It's okay? Do you understand step 1?
Yes.
Okay, good. Please don't change this guideline step by step, always. You create a mechanism to solve this. Step number 2 is find the Y-Intercept, because this is an important point. This is a super important point. X-intercept, Y-Intercept is always in any function that you want to do the graph, important point. Similar the thing we are doing in the quadratic function. But in this case, what is the formula? The formula is evaluation 0. So you enforce x equals 0, and you find the y that corresponds with this. Using function notation, it's easy to memorize this. Number 3 is find the x-intercept. What is the formula, professor? It's f of x equals 0, because you enforce the y equals 0. And in this moment, you have that equation, and you solve this equation. But let me say more. This equation is f of x, que es p of x divided by q of x. When you enforce it equal to 0, I don't care that part. That part is completely irrelevant. Because to be 0, the only condition that we need is que the top part, this is equivalent to say P of X equal to 0. Okay? So much better, at least for me, is replace this, because this is valid for any function. But in particular case of the rational function, the only thing you should do in order to find the X-intercept is take the polynomial at the top and enforce it to be 0. Okay, do you understand this or no? Do you understand that this guy do not participate in the game?
Yes. Yes.
Very well. At least in the game of finding the X-intercept. Okay. Number 4. Number 4 is vertical asymptote. Okay, always. Number 4 is vertical asymptote. And what is the formula to find the vertical asymptote? Well. You take the polynomial at the top and the bottom, Q. But after the elimination in the step 1, the wholes. Suppose que Q and you enforce it to be 0. This is the formula. So in this moment, it's important. I don't finish, but it's an important moment. Okay, always, I don't know why, it's my way. No another teacher, my way. This is a crucial moment in which you start doing the graph a little bit using decimals or by hand, either way. You, for example, you put the x-axis. Okay, this is my x-axis. And you plot the situation that we have. Well, Y-intercept we cannot plot because it's on the y-axis. But X-intercept, yes. So the answer, the solution for this equation, I don't know. Give me 1 solution, 2 solutions, 3 solutions, depending on the degree of P. So I plot this. Boom, boom, boom. I suppose that the solution for this is x1, x2, and x3. Suppose hypothetical, using the example. Okay, I plot that. Es obvio que es comma 0. That is the reason que lie on the x-axis. Okay, the solution of this, suppose we have 2 solutions. Suppose x4 and x5. And suppose x4, well, I don't know, any position, x4. Es a vertical asymptote, ¿no? Entonces, the vertical asymptote, I don't lie in that color. I lie always in black color. Don't lie. Okay, this is the vertical asymptote number 1, que corresponde with the x4. And this is the vertical asymptote number 2, que corresponde to x5. Suppose que the position x5, hypothetically, here, x5. And do the graph of this. Okay, so in this moment we have important information about the partition of the x-axis. Entonces now, in the last point, que es number 7, is determine the or plot additional point, extra point we need to complete the process. So now this is important. Look, I completed according to the partitions. How many points I select, Professor, additional? In number 7, I promise that you see that. Well, okay, the idea is, well, no now. Let's continue number 5, 6, and 7. In 7, I explain this idea. But in this moment, in number 4 step, I do the roughly sketch for the partition of the x-axis using the x-intercept, and using the vertical asymptote. Okay. Now, in number 5, it's obvious. The next step is 5. It's the horizontal asymptote or slant asymptote. And remember, both is impossible. Or you have horizontal or you have a slant. Entonces now, in order to investigate that, you are doing the famous degree analysis. Degree of the top, degree at the bottom, it's the same or it's not the same, dominant, at what value is, or a degree analysis and the conclusion, maybe you perform long division or no, depende si es slant long division, si es horizontal no necessary long division. Okay. It's a noise. Who make a noise? Who make a noise? Immediately I detecting who make a noise. Thank you. Okay, number 6, que is important and some students forgot, is analysis or test of symmetry. This is important and students forgot test of symmetry. Why is important? It's important because you need to determine, see, my function is even and odd or neither. Pero professor, what is important is, well, so you prove using the test of even, when you make a reflection, see, doesn't happen, stay the same. Now you take advantage of this fact because in the point, look, you take the positive point, 1, 2, 3, for example. What's going on? -1, -2, -3, -1, -2, and -3. So you determine que the function is even, like that, even. Well, to say you take advantage, you compute the function in 1, 2, 3, suppose que es this value, 1, hypothetical, guys. Suppose another value 5, and suppose another value 4. Entonces you don't need to find that because it's symmetric. So when you change the sign of the x, the y stays the same. So you don't need to do negative portion and positive portion repetition again, because I know that if the point was 1, 1, when you plug in -1, -1, 1, because the symmetry will respect the y-axis. Okay, you take advantages. Odd is similar, but it's different symmetry. When you make a reflection, you have a negative here. In this case, suppose que it's odd, you look as odd. The point frame of 1, 1 would be -1, -1. So it's the same value, but opposite sign. So you change the sign. In this case, no. They are twin brothers. In this case, no. And either, it's a mess. It's completely different. So definitely, you need to analyze the positive part, is the green part, totally independent of the negative part, is the blue part. So you take advantage of the symmetry. The symmetry helps us, even odd, to do not completely the job, sino 1/2. I prefer positive, no? Y I infer the negative part. Okay, entonces number 7, que es the famous topic que I try to explain, is plot additional points. Entonces the typical question is, well, professor, how many points? Well, there are no one definitely answer, depending on the problem. But we come back to the topic number 4. In the topic number 4, we have the partition of the x-axis. And we have, in this case, 3, I suppose hypothetically, 3 x and 2 assets, vertical assets. Entonces, es obvio que the minimum value of the x you plot in the 7th topic is at least one value here after x5. At least one value here in between x3 and x5. At least one value in between x4 and x3. at least one value in the x2 and x4. At least one value in between x1 and x2 y before x1 and value. Total 1, 2, 3, 4, 5, and 6. You plot more than 6, it's okay. In the majority of the example, not necessarily do everything, because I suppose in this case, hypothetically, 5 partition, 1, 2, 3, 4, and 5. So we have 1, 2, 3, 4, 5, and 6. One more. Okay? Okay, guys. No more blah, blah, blah. Let's do at least one example. And apply this procedure, step by step. Okay. May I erase the board or no? Come on. Are you sleepy?
Yes.
Too boring?
Yes.
You're sleeping now. Will you pay attention?
No, you
Isabella says, yes. Yes, what? Okay, now let's move on to the first important example, okay, in which I cover everything, every 7 topic in this order, step by step. Okay, example 1, full example. Because another example we are doing is partial. We focus on the vertical, we focus on the horizontal, no, this is full. F of x is equal 4x divided by x squared minus 4. And my final answer, my final job is do the graph, no? Include everything. Include the asymptote, any kind of asymptote we have in this problem, Y-intercept, X-intercept, etc. Okay, what is the first step, guys? Who help me? What is the first step in the guideline? I explained before. What is the first step? What is the step 1? Help me. Are you there? Marcos, everything okay? You are there? Abraham? Mimi?
I'm here. I'm just writing on the notes.
I know. Christy, come on, opinion. What is the first step in the analysis of the rational function? It's too long. Juan?
Identify the degrees.
Say again? No. This is not the first step. No. It's not the first step. No. Carlos, help me. What is the first step? Carlos. Say again? Carlos, increase the volume. I don't.
Be a factor simple form.
Simple form. What means simple form?
Oh, that they're all factored.
Factory form. Okay, factory form. Okay, guys. Step number 1 is factorization. Factorization what? Factorization the top, factorization the bottom. Let's do it. In the top, we have only monomial. We cannot do anything. But in the bottom, yes, we have binomial, okay, by the way, it's different of a square.
+2 and -2.
Exactly. This is a factory form. Step number 1. Do you follow me? Okay, I want to ask any question step by step in the example that we are doing. Okay, and you see some factor gets possible cancel out or no? Some factors cancel or no? Or stay alive? Some factors cancel or no?
Yes.
What is yes? Cancel or no?
Yes, they cancel. Can't
Who is
4
cancel?
and 2 cancel? No.
4 and what?
2.
4 and 2 is cancel. Wow, this is impossible. This is impossible. You cancel out the factor, the completed factor. But no, what the number inside. Hello. Okay, you need to go to the intermediate algebra. Okay, you cancel when you have, suppose you have 4x divided by x, x plus 2, x minus 2, and suppose hypothetically you have x plus 2. And then this x is cancelled, and this x plus 2 is cancelled. It counts the term in the parentheses, of course, in the parentheses. Okay, I understand. Some people believe. Suppose you can, for example, you have x plus 6, and you have 6 minus 6. You can cancel out this 6 and this 6. The answer is yes or no?
Yes.
No. Why no? Let me explain. This is intermediate algebra, please. So you have x times 6 divided by 6 times x or times minus 6 to make similar to this. My question, I repeat the question, I can cancel out this 6 and this 6? Yes. When it's multiplication, yes. The answer is yes here. The answer is yes here. The answer is no here. How do you know que no? Because when it's plus or minus, we cannot. When it's time, yes. Plus or minus, no. Do you understand or no? I suppose that you don't understand.
Yes, because they're the same sign. That's why.
You understand. Okay, for example, this example. 60 divided by 16. We can simplification this 6, yes or no?
No.
No. Why no? Because 60 is 65, for example. Make it more complicated. 65 is 60 plus 5. And 16 is 10 plus 6. So you cannot simplify because this 6 is 60. And this is just 6. And when you simplify, that means that they are equivalent and it's gone. Entonces, en conclusion, when you have plus or minus, never. However, when you have multiplication, always we can delete. Okay? Clear or confusing?
Clear.
Okay. So you need to go again to the intermediate algebra, or you remember that?
Remember.
So I repeat the question. Now. We can simplification something here in this expression or no?
No.
No. The answer is no. Therefore, we have wholes or no? Therefore, we have wholes. The wholes in this problem exist or do not exist?
Do not exist.
Do not exist. Very well. Do not exist. Because we cannot simplification any factor in this problem. Super good. What is the step 2? What is the step 2? Do you remember the step 2? What is the step 2? In the guideline I provide you before. What is the step 2?
The Y-intercept.
Excellent. Y-intercept. However, I asked you something. What is the formula for finding Y-intercept? Because I don't remember. What is the formula? Can help me to memorize.
Set the equation equal to 0.
Exactly. Plugging in 0. In which equation? In the original, or in the factor form? What do you think?
Factor form.
Factor form, she say. In the original, no? In the original, no? It's illegal?
You could do both.
And both. You are right, mister. And both. What do you prefer? The original or the factory form?
Factor.
Okay. Entonces 4 times 0 plugging in, no? 0 plus 2. 0 minus 2. 4 times 0 is 0. So I don't need to compute everything in the bottom because 0 divided by any number is 0. But by the way, negative 4, no? It's 0. This is important because when this situation happens, when the point is 0, 0, it's because this point is both. It's X-intercept and Y-intercept. But not necessarily, maybe in another example, we have another X-intercept. But okay, depending the nature of the polynomial and the top. Okay. Number 3, what is the number 3 step? What is the number 3 step?
Find the X-intercept.
Excellent. And what is the idea? What is the formula for finding that? What is the formula?
P of X equals 0.
Exactly. P of X is equal to 0. And who is P of X? It's 4X, no? Yeah, I don't care that part. That part is not important. Therefore, divided by 4, both sides. It's obvious that X is 0. And we get the same conclusion. Therefore, the important conclusion in this example is that we have only one. And they are perfect coincidence between Y-intercept and X-intercept. And this is an important point, I suppose. Very important. Very, very important. What is the step number 4?
Vertical asymptote.
Vertical asymptote. Very good. And what is the formula for finding vertical asymptote? What is the formula?
Q of X is equal to 0.
Exactly. Q of X is equal to 0. And Q of X, I can use in this expression or this expression. What do you prefer? The original or the factory form? What do you prefer? Hey, are you there? What do you prefer? The original, so you set out like that? Or you set out like that?
Original.
Either way, the original. He say original. I respect opinion. So X squared equal 4, square root both sides. X is equal plus or minus 2. Excellent. And we have two vertical asymptotes. Vertical asymptote number 1, vertical asymptote number 2. Add 2 and negative 2. Another 2 is no, I lie that way because there's already factor I separate in two linear equations. And you solve them separately, both negative 2, positive 2. You get the same answer. Okay? Either way, in this case. Now, this is a moment que I say you que I like do the partition of my domain, que is already a number, except the restriction that we have. I plot, for example, this important point, 0, 0 here, and the origin 0. This is infinity, negative infinity. I plot 2, 1, 2, 1, 2, negative 2. And we have two vertical asymptote, 90 degree vertical. At positive 2 and negative 2. 90 degree. Here, over there. Vertical asymptote. And another vertical asymptote here. Both are vertical asymptote. It doesn't matter what you call vertical asymptote number 1, baric acid. I call in the paper, in my paper, baric acid 1 and baric acid 2. You call different name, no problem. Entonces now, in the last topic, if you want to include additional points, maybe I select one guy here, one guy here, one guy here, and one guy here. Remember, in between the vertical asymptote and the only one X-intercept we have is in 0. 1, 2, 3, and 4. This is the minimum additional point I need to include. Okay, minimum. Okay. What is the next point in the guideline? Number 5. What is the number 5? Tell me.
Degree analysis.
Degree.
Analysis.
Okay. Because what is the reason I do degree analysis? Because I want to investigate what?
It's a horizontal asymptote or a satellite asymptote.
Very well. Because I want to investigate horizontal or slant. Okay, I copy again my problem, my function, original function, que is 4x divided by x squared minus 4. Okay, degree analysis. Degree of this is 1, no? Linear. Degree is 2. Okay. My question is, we have horizontal, we have slant, and we have horizontal special, or we have horizontal regular? Opinion.
Horizontal special.
Horizontal special. Very well. Horizontal special. And horizontal special is always at y equals 0, no? At y equals 0. If you want, and remember, don't forget, we have a slant, yes or no? Slant, no? No slant, only horizontal. Yes or no? Horizontal.
Yes.
Yes. Slant, never. Never. See, we have horizontal. See, your conclusion is according to the analysis of the degree, we have horizontal. Yeah. Immediately you discard slant. No slant anymore. In this example, no? In other example, maybe yes. Okay, but okay. Entonces now stop a little bit. When you have horizontal, I need to investigate if my graphic crossed the horizontal. And how you investigate that? Well, you take the original expression and you enforce it to be 0 because it's the value for the horizontal asymptote. But this I did before. I did before here. When by coincidence was the X-intercept. Okay, the answer is 0. So at this point, okay, no problem. This point is super famous point because this point is Y-intercept, X-intercept, and also is the point in which the curve crosses the horizontal asymptote. Okay, by the way, the horizontal asymptote, let me use another color to emphasize, is exactly coincident with the x-axis. I put a dotted line, no black, I put blue. This is horizontal asymptote, we only want to add y0. So this is point, is the point in our graph. I have no idea how to like my graphs. It look like that, cross it. Okay? Do you understand this idea or no?
Yes.
Okay. Now let's do example 6. Step 6, sorry. Get the test of symmetry. And the test of symmetry is super easy. I don't know, a student forgot. If you make a reflection, and verification is even or odd or neither. When you make a reflection, and the original maybe is 4 times minus x divided by minus x squared minus 4, no? And the top is minus 4x. When the bottom, you know, when the exponent is even, it's positive x squared minus 4. To see more clear, this minus, I propose you put in the front, because it's equivalent, no? Okay, now it's a crucial moment in which you compare this expression and this expression, get the original. Do you see some symmetry or no? Do you see some symmetry or no? Do you see some symmetry or no? No? Yes?
The odd symmetry.
Odd symmetry, very well. It's odd symmetry. Remember the formula for the odd symmetry is when you make a reflection here, this is minus outside. Excellent. This minus is very important. Indicate que es opposite sign. So when you select one value of the x, que I select positive, because I like positive, and you compute the y value plugging in into the original, I know that the same values, you suppose you select 5, positive. And the answer is, I don't know, 25. I know that when you select negative 5, it's negative 25. I take advantage this of symmetry. Please, don't forget that part. Okay, entonces now, to finish that, I in the number 7 step, que es the additional point, I select in my paper, I select 1 here, look, 1. Okay, 1 is okay here. I select 3, why not? And by curiosity, this is a minimum value because I know that -1 is symmetric and -3 is symmetric. Okay. And you select one more, but by curiosity, this is a minimum 2 point. Entonces, F evaluado en 1 is 4 times 1 divided by 1 squared minus 4, plugging in this in the original. F4 divided by -3 is -4/3, que in decimal approximation is 1.3 repeat, negative of course. Negative of course. Suppose now to complete the picture by hand, I put the y-axis. Okay, this is my y-axis. I plot that point, que es 1, negative something. This -1, -2 approximately is here, over there. I don't know exactly. Yeah, I don't care because in that way I'm doing perfectly. Okay, entonces I take advantage of the symmetry. Yeah, I know, okay, -1, I don't need to do anything. It's the same value, but opposite side, 1.3 repeat. And the point is exactly the same, but in opposite direction. Here. But let me make a zoom to see clear. 1,1.3 something. Entonces, I need an extra point. No, why no? Because I take advantage of the asymptote. Yeah, I know that my graph, when I actually say curve, you approach it to the asymptote but never touch. And this is similar. Sorry, my sketch. Okay. Approximately. This is by hand. Now, I plug in another point, yes, but no. Plug in 3. And 3 is 4 times 3 divided by 3 squared minus 4. This is 12. This is 9. This is 4. This is 5. 12 over 5. 12 over 5. I want to put in, divide. It's 2.4. 2.4 positive or 2.4 negative? No, it's positive, yeah. 9.5 is 2.4. Okay, so the point is 3,2.4 of, okay, 3, 2.4. I suppose a little bit. 2.4 here. 3, 2.4. This is my point. And what about -3? It's exactly the same, but opposite sign is -2. So it's -2. Okay, entonces to have one roughly approximation. Okay, my curve look like that. This is continuation the vertical in that direction. Okay. Oh, look, passing through this point and approach it and never touch the horizon because the only point I touch is 0. Similar idea happen here. You see the useful or the utilization of the asymptote. The asymptote give me some information can help me to understand a little bit the curve. And this arrow indicate this continue forever, but you know can never cross. The only point to cross is 0. And the horizontal is allowed. The vertical never, is illegal. Violation. Because it's undefined. Everyone follow me? Everyone follow me? It look like complicated, right? I suppose que no. This is not complicated. It's long. I understand. But okay, remember, we are taking advanced mathematics. It's not kindergarten algebra, no? Number 1. Number 2, you need to remember the concept and the guideline step by step. 7 steps. 1, 2, 3, 4, 5, and 6. Okay, just in case I want to finish, look and show you the decimals of this part. Okay. Do you see decimal? Do you see or no? Do you see? Yes or no? Answer me.
Yes. Yes.
Okay, this is example 5. Look at the example 5. Example 5 is 4 over x squared minus 4. You can see clear like water. Okay, we have two vertical asymptotes at 2 and -2. We have one horizontal at y0. It's obvious that the symmetry of this function is odd. You can see, you'll be familiar with it when it's odd, the symmetry can look like, and the typical point I plot was this. I plot, for example, 1 is -1.3 repeated, and -1 is the same value, but opposite sign. This typical odd symmetry. Any question? I promise that we continue working next time with more example, more complicated of the